Okay, I started work with all solar desalination, but we have evolved that into what closer to what industry wants. Was right for a single household or a small community, but when you get into the six-figure barrels a day, industry wanted a lot more capacity. And we have taken the basic physics we learned in solar and transform it so we can work on almost any wastewater. And you'll see our technology is outside the box by way of most of the technologies, but we can purify seawater, wastewater, produced water, saline water, and it turn out very high quality, high purity water. Next slide. We started off focused primarily on produced water. I realize that's rather controversial in New Mexico, but basically produced water from an economic standpoint, the oil companies spend $5 billion a year in the Permian Basin to pump their produced water underground, but it's a waste of water and it causes earthquakes and contamination of fresh water. So we feel like that not in addition to the value of the pure water we produce, we could eliminate that expense for the oil companies. Next. Basically, this may be preaching to the choir here, but for every barrel of oil that's produced, you get 4 to 8 barrels of contaminated produced water, which is classified by the EPA as hazardous waste. It has to be treated. And of course, both New Mexico and Texas have a consortium of people been trying to figure out how to treat that water. We have a way to treat it. Next. Basically, we are repurposing shipping containers. In the process, we've shortened as SWAP, saltwater purification, and we can purify produced water for less than $1 a barrel, which is less than what the transportation costs. And the other thing about it is our process is modular. We can locate at the well or a few modules in a group of wells, save the transportation costs, which is usually about 2/3 of their cost of about $5 billion that they're spending. We've worked with water from Shell, uh, a midstream company in Midland, and we're also looking at working with local governments because basically each one of our units that you see pictured there is a shipping container can produce about 20,000 gallons a day of distilled water. Next. This is an overview, and again, this is oriented to the investors, but basically, we start with any wastewater, which contains water, waste, hydrocarbons, and salts, of course. We actually, one of the options we have is to put a steam stripper in place to strip the hydrocarbons out of produced water. And we actually use those hydrocarbons to drive the steam stripper. So the steam stripper is nearly about, it depends on the quality of the produced water, but we can get up to 50 or 60% of the fuel we need for the steam stripper from the hydrocarbons included in the produced water. What results from that is the hydrocarbon-free uh, water and salt mixture, and that's when our desalination technology takes over. Uh, the table at the bottom shows some of the feed water concentrations. We started at 233 parts hydrocarbons, got it down to 2.7. The salt started at 27,000, and we got it down to 80. Those were just some of our early test work. Now, if you go to the next slide, it looks very much like this one, but I've added some bullets about the technology. First of all, we've come up with a design that gives us an evaporation area 180 times the equipment footprint. That is a significant impact on the evaporation capacity. The other thing is the evaporation technique that we use evaporates water at 5 times the rate of pool or pond evaporation. You multiply those two things together, and basically for a 100-acre produced water evaporation pond, our equipment would could do more than that in simply an acre. The product, our product water, because it's thermal desalination, we say less than 5 parts per million salt. Well, we simply haven't gone through the clean room analytical steps to see how much lower than 5 parts it is. But basically, our process produces distilled water, and we can get the hydrocarbons below 4 parts per million. Actually, we have an option with the steam stripper. We can get the hydrocarbon level down into the single digit parts per billion. That's single digit parts per billion. That's way beyond what's required. Actually, we've done some research. You guys may know more about this than me, but what I've found is that in Texas, the rainwater runs between 2 to 4 parts hydrocarbons just from automobile exhaust.
Wow.
We produce better quality water than rainwater. I mean, it's not anything heroic. That's just the result of the kind of processing we do. We also have the option for zero liquid discharge, or we could convert the salt that we bring in to the 10.5 brine that they use in the drilling step. Now, here's the key features of our technology. First of all, we operate below the boiling point of water. We never boil the water we take in as feed water. It's continuous humidification, dehumidification with closed brine and closed air circulation. But basically, we've come up with ways to increase the evaporation area and increase the evaporation regimen to the point where we can do our equipment will reduce the size of getting rid of that produced water by just 2 orders of magnitude, and you get the pure water as a result, which you don't get out of a pond evaporation, of course. And basically, pond evaporation, I would say, is probably our primary competitor right now, by way of getting rid of produced water, besides pumping it underground, of course. Of course, the other thing about pumping it underground, you have to transport it to the well, and the transportation cost is 2/3 of those costs they report. So in effect, and the other thing about operating below the boiling point of water, it introduces 2 key things on the economic side. We can use renewable and waste energy, and the renewable meaning solar or geothermal, and waste energy. In fact, we're planning our first industrial module built onto a trailer, and we'll be able to run it by and large with the exhaust from the truck that's pulling the trailer.
Wow. That's significant. So also,
Hill,
obviously,
operating below the boiling point, we can recirculate almost 80% of the energy we put in. So thermal desalination has always had a bad rap because of the huge energy cost. But when you recycle 80+% of it, and some of what you're putting in is free, the primary energy cost gets down into the single digits.
Well, and going back to your pond evaporation thing, ponds are almost impossible to get a license or permit for now. Well, I made a broad statement, depending on your state.
That too, yeah.
And you lose the water. So, you're basically farming water here, Hill.
Yeah, exactly right. And we're eliminating a hazardous waste. So, I mean, in that sense, it's a double hit. It's like a 2-bladed axe.
That's right.
Okay, next.
All right.
This is a comparison that we put together. Undesert is in the blue on the left. We can handle feed up to 200,000 parts salt, and most of the Permian Basin water is around 150. Pumping underground, they can handle any level of salt, but reverse osmosis can't really handle much over 50,000 parts because the pressure gets too high on them. So we can handle the Permian produced water as it is. And that's probably processing wise, the main competitor would be reverse osmosis, besides pumping it underground. Of course, Texas was second only to California in earthquakes last year, because of and it's derived directly from pumping the produced water underground. And then the graphic at the right basically shows seawater at around 25 or 30,000 parts. Reverse osmosis can handle about double seawater. The Permian Basin PW is about 4 times the concentration of salt of seawater, and we have fed up to 8 times the concentration of seawater.
Very impressive.
Next slide. This is a cost comparison basically to pumping it underground. Our energy cost is much less, especially when you include the energy it takes to transport to a central injection well. There's no seismic or freshwater risk with our approach. The transportation cost is a lot less. There's almost no regulatory burden. The water we produce, if you don't have an otherwise use for it, we can save money by simply putting it into the roadside ditch because it's that good a quality. And of course, the other thing we've looked at, sort of on the agricultural side, John, we've actually proven that we can grow commercial pine forests in raw deserts with the water we produce.
That's amazing.
We have a test plantation in Alamogordo in the desert, and our trees are growing 10% a month during the growth season.
Wow.
Next slide. The environmental benefits are myriad. First of all, we recover 80% of the feed water. I mean, a single module yields about 20,000 gallons a day. And again, we're looking at grouping modules to meet the oil companies up in the 50 to 100,000 barrel a day range. We have the option for zero liquid discharge. We've actually proven that we can take the brine that we produce, put it out in the New Mexico sun for a couple of days, and it makes a 0.5 millimeter of dry salt. So we can take it all the way to dry salt with the final drying pan step. The energy efficiency compared to other thermal approaches is phenomenal because of the fact we're operating below the boiling point. We can recycle most of the energy we put in. And then, of course, it's set up for 24-hour operation. We'll have data monitoring and remote monitoring. But we can group these. What we're looking at probably is grouping 40 of these containers into a single group and serve them all with one pump and one air circulation system. Next slide. Now, what market are we targeting? On the left, the energy companies, because of their disposal cost, the investor people telling us that's where the money is, so that's where we're headed. But we also have a proposal right now. Since our water is such high purity, it is premier feed for hydrogen production. So we actually have a proposal before the Navy right now to operate a electrolyzer hydrogen production system on the pure water we produce. Of course, agriculture. I mean, right now, the statistic I heard, New Mexico spends 75% of its freshwater resource on irrigation. Our water quality easily meets irrigation requirements. In fact, you might have to mineralize it a little bit because it's such low salt, or toss in some feed water or something or the other. And then we actually have talked to one of the local communities. Tularosa is a north neighbor to Alamogordo, and Alamogordo is drawing so much water it's pulling salt into the Tularosa wells. They have shut down 3 of their wells because the salt content is too high. We're looking at the possibility of applying it there. So basically, we could apply our process to one of their wells, and they can add our pure water to the rest and get everything below potable standards. We're looking initially on the right-hand side of the U.S. market, focusing on Texas and New Mexico, although we have some interest from Pennsylvania as well. My original solar work was done in UAE outside of Dubai. They're interested in the new technology. And we have a proposal in front of Hi9ll the sustainable city that Saudi Arabia is
Oh
looking
yeah.
at putting on the Red Sea. Basically, we made a proposal to them to take, and by the way, we have fed RO brine to our process and successfully process it to distilled water and dry salt or heavy brine. And
What
our proposal in Saudi is to grow 10,000 trees next to their RO unit close to Jeddah.
what kind of recovery you get? I mean, I guess it depends on the brine concentration, but is it 20%, 50%?
No. We run close to 75 or 80% because you see we can concentrate. We've concentrated up to 350,000 parts. That's the
Really?
limiting factor is how yeah, our equipment is very tolerant because we operate at a high enough temperature. Most of the salts stay in solution.
Okay.
Again, but we don't go to boiling, which is what causes scaling and
That's
fouling.
right. That's right.
Okay, so next slide. Uh, Basically, the U.S. is right now the leading oil producer in the world. Uh, so we think that's a dealing with their produced water problem is a key one. The Permian Basin generates 1 billion gallons of produced water every day. That's a sizable water resource going to waste, and most of it's being pumped underground. Texas contributes 40%, 42% of the Permian Basin. And of course, New Mexico, the oil production in New Mexico has been increasing at a galloping rate. They're the second oil producing state in the country now. That's a new a recent development. Next. This is a track of our technology development. I started to work on an all solar basis in 2012 at the Bergendorf Research Facility in Alamogordo. We progressed over the years and now have the swap design, which pushes us up from the 30 liters a day per module up to 500 barrels a day per module. So we've made leaps and bounds by way of capacity in order to reach the industrial customers. And by the way, one thing, the Los Alamos National Laboratory built a thermodynamic model of our solar unit, and they're now taking that model and modifying it to adapt to our newest swap design. And we expect to have within a month a full thermodynamic model of our process for use in scaling up. Next, this is a little bit of a look back at history. The place we started in Sharjah, just east of Dubai, was a calcic horizon. Anyone who knows anything about desert country, a calcic horizon is basically parking lot. Nothing will grow there. That's what it started out as. And now it's an oasis. They have a 5-level hydroponic system, and they're harvesting 10 kilograms of organic food per square meter per month year round using desalinated water. Next. These are some of the folks we've worked with. We've worked our 2 contracts with our 3 contracts with the national labs or through NMSBA, a big help for us. We were part of the Shell Game Changer program. Martin Water is a midstream company in outside of Midland. We process their water to full purity. We were part of the MESS Challenge and TechStars programs. Of course, our original research work was at Bergendorf. We were in the top 10% of the X Prize for carbon removal, growing forest in the desert. And of course, we worked with both Shane Walker in Texas and Mike Hightower in New Mexico on the consortiums. Yeah, we're right now at the stage of needing to raise money. And if anybody knows anything about trying to do a startup company operating as far outside the box as we are, it's a challenge. The investment community is normally risk averse, and with the general uncertainty that's been going on lately, their risk aversion is like on steroids. So we're having trouble getting you know, we're looking at a $2 million pre-seed to get it in industrial production. But hell, we can build our first trailer-mounted demonstration unit to take around to people's ponds and show them what we can do for a couple of $100,000. So we sort of have a dual track of. So if anybody knows someone who's interested in launching into a radical new desalination approach, give us a holler because we need help getting that first. Once we get that one, we can bring that one, pull a trailer mounted, pulled by a pickup truck, and run it freestanding energy out of their pond and turn their pond water into distilled water right before their eyes. Next, well, you can see this is again, we're getting to the investors' interest. This is our financial projections. Next, unless someone wants to spend time on this, our team, basically, mine is my background is chemical engineering, and I did the initial research. I had the original patents on this. We now have 5 patents on this technology. Nick Seed is a CEO. He founded a software company, sold it to Adobe back in 2010. His background is both engineering and MBA. And we have May Akwari, who's formerly with BP. She's our COO and a major contact. And we, by the way, just last week, and if any of you know Thomas Lord, the second guy from the left down there, he's an experienced commodity trader, and he came on board as our financial advisor last week. So we're and Morris Clark, by the way, is retired marathon all officer. So we have a team we feel like is poised to get going. We just need to get the risk noise turned down low enough to get us going. Next. And this is the pictures that I mentioned to you about that carbon credit. If you take a look at, there's a lot of oil properties between oil wells along pipelines and so forth that are just basically barren. And we can take the water we purify from those wells and convert it into that after picture you see there on the right. I mean, we have, on the left there, you see, we've done the calculations by foresting 1% of the non-polar deserts, we can stop global warming in its tracks. And if we can forest 2%, and there you'd be desalinating seawater and so forth, we can actually get us back to the 70s on global warming. Next. There's our contact information, www.undesert.com. And there's one thing, well, look at it. I'm not sure I can explain this. This is some sort of a special offer. You can stop with the slides. That prior one was basically the end of my presentation.
Okay.
The rest of them are appendix. But here's the thing: we've talked to a guy who has built. He's specializes in taking technology from the pilot level, and we have pilot data that Los Alamos National Lab is now converting to a full industrial scale. The pilot data. He's taken pilot technology to full-scale industrial technology, done some work for the military, but basically he has built 6 or 7 different water purification technologies. His comment after he signed our NDA and looked at what we're doing, he says, "Why the hell hasn't someone done this already?"
Fantastic, Hill.
That's my presentation. I'd be happy to try to answer any questions. If you need to go back to the slides, he can get it back to us, I guess.
So questions? Obviously turning waste heat in that steam stripper process, and then essentially distilling below boiling point. That's the magic part of this entire process.
Absolutely right. Yes. That lets us use cheap, free energy and to recycle the energy we put in. That's the key.
And you said the hydrocarbon stripping gets you 40 or 50% of your energy. And total cost is for barrel is about $1, which is perfect. That's 10 years ago, oil industry wanted $1 a barrel. It should be a lot more now with inflation.
Yeah,
But
yeah.
they're still hanging on to that. So
Oh yeah, yeah.
where's the hack, Hill? I mean, there's obviously some magic going on in the middle there. Is it steam recombination? Is it, I mean, just in a general
Well,
category?
it's okay. It's general. It's continuous humidification, dehumidification with a closed brine circulation and a closed air circulation. So we have the water and the brine going round and around and around. We're adding makeup water, taking off concentrated brine. We set up the modules in stages. So we take a first cut, a major cut first, and we have some later stage ones that cut deeper. But basically, the magic is the amount of surface area for the footprint of the equipment. That's a factor of 180. And the evaporation regimen, pond evaporation, well, pond evaporation will give you about 200 or 300 barrels a day per acre, roughly.
Right.
Our equipment will do 30,000 barrels an acre.
Jeez. Let's see, Mr. Hawley, you had your.
And it's a combination of high surface area and the evaporation regime we use. It's not anything that's, as far as I know, ever been used in desalination before.
Okay. John, you have your hand up, so.
Yeah, do you have anything going in northern Mexico? I'm particularly interested in Chihuahua, just adjacent to El Paso. And then the other
Well,
thing,
I mean, my partner lives in Los Alamos. Is that northern enough for you?
Mexico, not New Mexico.
Mexico, Chihuahua.
Oh, northern Mexico.
Yeah. Do you have
I don't know.
there?
I don't know enough drug lords to operate in northern New Mexico.
What?
Well,
I mean, northern Mexico. Excuse me.
There's obviously lots of opportunity in Mexico.
Yeah.
The problem is
some
getting
secret for surviving operations in Mexico?
It's not so much that, Hill. It's getting through the Pemex, corruption, and we've been working on it for. Deborah and I've been working on it for 10 years. So Mexico's interesting, John. Did you have a particular site you were thinking about, or you just like the area?
Well, no, I'm thinking about the area that the border, like Jerry Pacheco, the border group that works out of Santa Teresa, both Mexico and the United States. Pemex doesn't have anything to do with it.
Oh, okay. All right.
Can you put that name in the chat, John?
What?
The chat feature on Zoom. If you wouldn't mind putting that name in there for Hill, that'd be groovy. Or you can email it to me and I'll get it.
Yeah, I've got your email. Do you have a phone number too? I saw it and then I lost it.
Yeah, I'll put mine. Well, yeah, if you want to write it down, I'll give you my phone number now. It's 318
315
315 is the next three numbers.
315
1534.
1534. Yeah, I'm partially deaf and I no longer text or type very well.
Okay.
Arthritis, but I'll be like Arnold says, or the Terminator says, I'll be back.
Okay.
There you go.
Mr. Doss, sir, you had a question?
Yeah, it was regarding the food irrigation for food products. You talked about being able to use produced water, and there's still some bad chemicals in the produced water. Have you been able to get those down to where you could use it on a irrigation for food products?
Well, two things about that, Russ. We have a proposal from a national engineering company. We can process with the steam stripper design. We can process the produced water to single digits parts per billion hydrocarbons. Okay. And the other thing about that is in Texas, rainwater runs 2 to 4 parts per million. So if yes, we can easily get the water purity down below 2 or below rainwater.
Okay, because it's my understanding that they're still struggling with some of the produced water chemicals, even identifying them. So you're saying you just lump them together into hydrocarbons, and they're below the level of
They quoted us below 10 they quoted us below 10 parts per billion hydrocarbons.
Okay. Okay.
Without identifying the hydrocarbons. They simply said their design reduces the hydrocarbon content below 10 parts per billion. Now that puts a steam stripper in the design, and that changes the cost picture a little bit. But again, depends on how low you need to go. If you can stand for it to be only as good as rainwater, that we don't need that much heroics.
Yeah, but Yucca Flats proved that the government doesn't care about background. So Dr. Graham.
Hi, Jerry.
There we go. Hey. So you sort of started to answer my question. So now I'm reformulating it in my head. I'm an aqueous geochemist, worked with Grizz for a long time.
Okay.
So of course,
welcome.
all hydrocarbons in my mind are not the same. I guess I'm interested to find out what kinds of analyses you do for hydrocarbons and how you're comparing them to the rainwater. I totally believe that there's quite a bit of hydrocarbon dissolved in rainwater. Doesn't surprise me one bit.
We've done a bit of a
you did
survey, and
that.
it runs from 2 to 4 parts per million.
Of what?
It kind of depends, urban and rural. But yeah.
Yeah, and of what? What are those hydrocarbons composed of in your exit stream? Because I know the state is very, very concerned about very particular constituents. I think they're still developing those questions, certainly. And I'm curious to what level of detail, I guess, that you've been going to on that.
What we have seen so far, and this is very preliminary, don't hold me to this at all. What we have seen before is nothing lighter than xylene. But
Not a surprise.
We don't really have the kind of precision I think you're talking about, that we haven't gotten that far yet.
Okay. You may want to consider doing some in-depth analyses on occasion before you get asked about it. The other thing I wonder about in relationship to that, when you say you have nothing lighter than xylene, that implies a pathway through air to rainwater and other places. What are you doing in terms of monitoring air emissions or air permitting, et cetera, with your system?
We take all of the hydrocarbons. The steam stripper converts the hydrocarbons to 2 streams. One is gaseous fuel, and the other one is liquid fuel. We burn both of those in the boiler that generates the steam that drives the steam stripper. Mm-hmm. So they're burned to CO2 in the firebox of a steam
assuming
boiler.
100% efficiency.
Well, okay, right, yeah.
It's a pretty good one, I would assume. I mean, you wouldn't be touting it if you didn't feel confident with it.
Yep.
There's your out.
Yep.
I'm just curious, because pretty much anytime we burn something, it's not 100% efficient. So I'm just curious.
Oh, yeah, right.
Air permitting has become an issue for you.
Yep.
Not in Texas, it won't.
No.
Well, a steam stripper doesn't require anywhere near as much steam as a distillation column, for instance. It's much more effective use of steam. So the steam load is fairly low, but there is that's the way we dispose of the hydrocarbons, is to burn them to produce steam for the steam stripper. Okay. And by the way, we have to probably add a little bit of either natural gas or propane, because most produced waters will not give us totally enough fuel to drive the steam stripper. It's around 50-60%.
Okay.
Thanks.
James?
You're on mute, buddy.
Thank you. Thank you, Chris. Hi, Hill.
Hi.
Good presentation. I look forward to looking at it in more detail. So a couple of questions. I'll hit on the quality of the incoming water first. So my impression would be that if you're working, you've been talking about produced water. So is it true that you're really focused on produced water rather than produced water with frac water mixed in with it? Certainly you'll have a better outcome if you just work with produced water, I would imagine.
Sure. Yeah, right. But in the field, it's a little hard to keep that segregation, I'm afraid.
Yep, yep. And so given that, one of the other classes that I understand is relevant here with the frac water is the per and polyfluoroalkyl substances.
PFAS, yes.
Right. And those can be, really low parts per trillion level. PFOA, PFOS, four parts per trillion. So something to look at. Now, when you're pulling from a pond, do you have any concerns about biological contamination of your system? Do you need to do pre-treatment to remove biological?
Well, basically, we do nanofiltration because our process is not particularly tolerant of suspended solids. So we do uh, uh, nanofiltration as an initial step. Now we have the option, one of the options on our process, and that's the beauty of it. Our air inventory is really fairly small, and it would be a minor addition to our flow sheet to take all the oxygen out of that circulating air. So that basically we would be circulating nitrogen. That would give us a major amount of control over the biological issues inside.
Where they're mostly aerobic. I guess you're assuming that.
Yeah, right. Because we have a small inventory of fixed circulating air, and it would be a fairly easy step for us to add a deoxidation, or take the oxygen out of it, and then use oxygen-free makeup.
Okay.
As needed.
Gotcha. On the carbon credits, so you have nature-based carbon credits, technology-based carbon credits, and when people are out working on forests, that's usually classified as nature, but this seems like it would be technology-based because you're producing the water through a technological process. Have you talked to anybody about how that would go if you followed that carbon credit stream through the process? Would it be nature-based or technology-based?
We haven't had that discussion. We do have a group of people who are looking at giving us certified credits for growing forests, in other words, afforestation, and convert those to credits. I think those would be, well, I don't know. I think they would be nature-based. I'm not sure I know that distinction, James. Sorry.
Yeah. So what you're pointing out is the advantage you have is producing this water that's useful. Without that water, you're not going to grow the forest in the desert.
Exactly right. Yeah.
So,
not in the Alamogordo or the New Mexico deserts. The trees simply won't grow there. And we found that they grow.
Yeah.
They grow very well because the photosynthesis is put on steroids by the 6.5 kilowatt hours a square meter per day.
Yeah. Well, thanks. Those are my questions. Thank you.
Okay. Thank you. Good questions.
Other questions?
Well, I've got a question for you then. If you don't have, would someone have a question? Go ahead. Go ahead, Felix.
So I've got over 30 years in the industry, and that associated with desal RO. And I've been a previous general manager for several water districts. So you'll find me more on the operation side of things, but I'm very interested in your technology. And I'm kind of curious, you said your tech is trailer mounted, skid mounted. Is that right?
Well, our modules are basically an 8-foot cube.
Right.
8 by 8 by 8. We can put that on a trailer, take it across the highway with the associated equipment on the same trailer, back up to someone's water source, be it a pond or where the water's coming from, and run the operation right there. Energy self-sufficient.
And these units, are they stackable? Can you do add-ons?
Oh yeah, well yeah. In fact, in our industrial design, we're looking at a cluster of 40 containers stacked too high, actually in a circle, so that the auxiliary equipment is inside of that circle, and the piping runs are almost nil.
Right. Okay. So that being said, what do you see as far as your footprint goes? What kind of production do you think you're feasible of doing?
We see an initial productivity, and again, we're moving into an area that's pretty well unexplored, so we don't have a lot of reference material in this. But we see that we can generate water at a rate of about 30,000 barrels per acre per day. Does
Okay.
that answer your question?
Yeah, it does. It does. It
I
very
mean, if we
intrigued.
that's stacked too high. If we stack them 4 high, it goes to 60. So
Yeah.
there's wind considerations and all the rest of that stuff about how high you go and all that kind of thing.
Right, right. Always curious about the BAT out there, the new technology, best available technology out there, and
Yeah,
how we can put it
yeah.
to good use.
Well, I mean, uh, at 30,000 barrels a day per acre, that's a pretty efficient deal. And again, it's because of our area multiplier and our evaporation regimen multiplier that we can do that.
Right,
And
right. I may
basically,
have to.
we can do on 1 acre what they can do with a 100-acre pond.
Okay. All right. Very intrigued. I may have to reach out to you and set up a separate meeting and find out
Okay, sure, be
how
happy to. Who is the Seven Seas Water Group? Never heard of you.
Seven Seas Water Group is they've got over 30 years experience. They provide desal RO technology, wastewater technology. And the reason why I'm here is they reached out to me to see how I can be of service. I had again over 30 years experience in the water industry with a background in engineering, and I was a water resource consultant. Before that, I was a general manager for several districts. And they reached out to me and they said, "Hey, we like what you're doing in California and in Arizona, and we're wondering if you can provide that for the Southwest region of the United States." And I said, "Okay, maybe." I'm all about paying it forward and being of service to several communities. And so they reached out to me, and I'm helping them out with trying to reach out to communities to see if we can help them with their vulnerability assessments, conducting walkthroughs, and see if we can help sustain them with their water resource needs, help diversify their
Well,
water
look,
portfolios,
yeah.
if you will.
But we have processed 4 different grades of RO brine to distilled water and dry salt. I just put my email in the chat.
Okay,
If you want to grab that, I'll be happy to set up a correspondence with you, Felix.
sounds great.
I
Appreciate
mean,
it.
basically, as a startup company, we think we got the technology. I mean, and by the way, our technology is fully patented, so we have the IP handled. But as a startup in a high risk investment environment, we're struggling a lot. So some sort of a partnership is definitely in our view as a possibility.
Yeah, Morgan Stanley is backing us up financially, and so we could come in to a community and take care of all the financing, one-stop shop. We have all the legal team, we have the engineers, project managers, all that on tap. And that's what won me over. And I said, "Well, you gonna let me run with the ball? You gonna let me quarterback?" And they said, "Yeah, you run with the ball, and you go in there. You know people, you know what they need." And the latest and greatest that I'm very concerned about is the new ruling with PFAS, 40 CFR. And so all municipalities now they've got 3 years to figure out what kind of PFAS they got in their groundwater or surface water. And then they have another 2-year deadline after that to put in the BAT, the best available technology to remove that. Of course, one of those is
Sure.
going to be RO. So,
Well, yeah, but here's the thing on PFAS, it without the steam stripper involved, PFAS winds up with our salt. But what that means is by the fact that we eliminate the huge 80+% of the water that's there, thermal breakdown of the PFAS is hugely cheaper than it would be otherwise because you get the water is taken out of the equation.
right. And not only that, I think there might be a potential for us to partner up because I see that maybe you could be of use with regards to green energy, hydrogen.
Yes, absolutely right. Yes.
Yep.
We have that proposal before the Navy on that.
Yeah. So
I haven't
we'll
heard
definitely
from
have
it.
to
We'll hear
talk.
from it in the fall.
Jim, you had another question, comment?
Yeah. Yeah, thank you. So Hill, yeah, so you mentioned on the nanofiltration and relative to the PFAS, is it your position that most of the PFAS is being removed by the nanofiltration up front?
No, not really. Not really. It winds up with the salt or the brine.
Okay, and so how much, you can go to dry, you said, what would be the volume, and I don't know the density, whatever, but for 30,000 barrels per acre per day, just to give me a feel of context, what kind of block size of salt would you be
Oh.
looking at?
Well, I mean, we've looked at possible uses for that salt, and PFAS complicates the hell out of that, of course. One of the things we looked at, I mean, basically, we've taken our brine, put it in the New Mexico sun for 2 days, and it goes from 3/4 of an inch of brine to about a half a millimeter of dry salt. Okay. One of the things we envisioned is build that up over a year and a half or so to 3 inches thick, break it into 3 inch by 8 inch rectangle, build buildings out of it, stucco the inside, the outside, and sequester the salt as a structural piece. There's a city in Egypt built completely of salt blocks, and I've got their mortar recipe.
That's interesting. Also,
So I mean, I don't know. We have not really explored the salt, and particularly with the PFAS complication, we have not developed that aspect of it. We've been, of course, focused on the desalination and the produced water part.
so I was going to say Hill and Felix, our company commercialized a bunch of stuff that Jerry led the project on for multiple labs. And we accidentally discovered we're trapping long chain PFAS, and we're doing it for, a half a penny a gallon.
Wow.
So the question is going to be, do you want to try to destroy on site, or do you want to try to concentrate that PFAS, create even, I guess it would be a concentrated, even more hazardous way. It's already hazardous, right? So like nuclear power, we're into concentrating contaminants, because, it's a question of how dead do you want to be from
Sure.
1 part per million or half part per million. I'd
Yeah,
love to talk to you guys about working on this new project with us. We're going to put in an SBIR for the Air Force,
Oh, great.
AFWorks
Okay.
lab, and fast track it. And if I've got users ready to go,
Wow.
then that's going to, reinforce that proposal. We can talk about it offline. I've got your email, Felix, and
Great.
yours,
Okay.
Hill. But I didn't want to leave this without saying so, because there's a couple Line Water folks on, and they'd be like, "Why didn't you bring up our media?" So I'm bringing up our media. So
Okay. Yeah.
the neat
Well, I mean,
thing
again,
is
as a struggling startup with a breakthrough, we're looking for any opening that will
so
get
are
us
we.
past.
So are
Yeah,
we.
understand.
And
Okay.
the one thing we
Okay.
don't do is salt concentration.
We handle that easily.
Apparently, yeah. So there could be some real synergy here. It's our inability to do something with salt, even though we can remove hydrocarbons, metals, sulfur compounds, radioactive materials. We've already gotten into that. And most of this media is reusable. You field recharge it, so your media cost goes way down compared to, activated carbon, or even some, in the
Sure.
case of
Yeah.
PFAS, even some ion exchange media. So there's lots
Well,
to talk
you
about
can
there.
appreciate it. Yeah, thermal desalination gets past a lot of the problems with other technologies, but what we've done is solve the energy hickey that thermal
That's right.
desalination brings with you.
Well, there's a waste heat desal company out of Australia. They're in a different market space than you are, but they're proposing to use our reactors after their salt concentration, because they're not getting to high enough temperature to grab or kill those hydrocarbons, and our media collects
Sure.
that stuff really well. So yeah, you just never know how you're going to put stuff together. It's, as
Sure.
Jerry says, you got to test the hell out of everything and see what works.
Yeah. Well, let me just mention one other thing real quickly. Nick Seat, my co-founder, is dual citizenship, Australia and US. He was born in Australia.
Okay. Very good. We'd like to respect everybody's time. Anybody got any last minute questions or comments?
Well, I mean, again, I have a question for the group. Does it
Okay.
sound like something? Does it sound like something new to you?
It sounds like a natural evolution of other processes, and you're getting to the market first, and that's enough.
First principles, I think
Yeah.
you've gone to first
Yeah.
principles.
And it's the same thing
Good
with our tech. You know, it's an evolution of what people
Yep.
have been doing in other areas, and we
yeah,
packaged
sure.
it, and that is the difficult part, is actually engineering it and being able to put it out in the field and have it work day on for years.
Mhm.
Well, that guy I mentioned who said, "Why in the hell hadn't someone done this already?" is chomping at the bit to build that first trailer mounted module.
Oh, cool. Well, that's good. We are raising money to do the same thing.
Okay.
Everybody wants a free pilot.
Yes,
So-
John. John's got his hand up.
No,
Oh, yeah.
I'm just interested in brackish water, not produced
Yes.
water, just water that is in the 1 to 10,000 parts per
Sure. Yep.
liter range. And that's the one, like in the basins, like Waco Bolson, where Tuller Basin,
Sure.
or the Mesilla Basin, we have, in terms of, we have huge reserves of recoverable brackish water. And this has the hydrogen, green hydrogen comes in, all this. And we need to, I think, produce water is a couple 100,000,
Sure.
and
Yeah.
we're talking about stuff you could drink it if you were constipated, and get along. Well,
Yeah.
but
Thanks.
it's a really that's the water that I want to go for as
Yeah. And John, look,
hydrogeologist.
that's a piece of cake for our technology, and that's the water I did all of my research on in Alamogordo, is 3,000 to 10,000 parts.
Yeah. Well, thank you.
You're
We'll be
welcome.